Howdy guys, today I'm going to explain a little bit of how the power system works in Battleforge. I'm going to outline the math for you a little bit. So you can see here I've got an online graphing website called Desmos. This is just going to let us graph. So I've plotted on this axis I've got time, that's our t variable right here, and on this axis right here I've got the power, so that's p. So as you can see here, this will explain to us at what point in time how much power we got at a certain point in time. So this variable right here, W, stands for wells. So right now I've got that set to 0. So this will model a system where a player has 0 power wells. For instance, if we put 1, that'll make it rise higher. 2, 3. So you can see how the wells affects it. Basically, the wells are going to be equal to, it's going to be a linear path, so it's going to influence it going into a straight line like this. We've got our V naught, which is our initial void power. This is very influential on how the void power will be gained. So right now I've got this set to 100. In likelihood, a more average number would be something like 400. Could be as high as maybe 1,000. But right now we'll just leave it at 100 just to see some stuff. We've got 1 minus 49 over 50. This is a calculation I derived. You can check out my thread, Battleforge Math, if you want to see how I came up with this. But this basically models the void power of this curve here. And then P naught we have is just your power when you start. So for instance, if we set our void equal to 0, and our power equal to 100, we're going to have 100 power. That's not going to change because we're assuming that we're not spending any power. Okay, so whatever your initial power is, that's how much power you got, period, right? So I'll set that to 0 right now. The wells, as I described earlier, is going to make a linear path. So if well equals 1 is going to be a linear path where the time is equal to the power. It doesn't look like it's at a straight 45-degree angle, but that's just because the axes are not, it's not a 1-to-1 ratio. But you can see that changing the slope of the line, it's still a straight line, however the power wells affects it. And then this V naught will affect the graph like this. So that should give you a rough idea of what's going on. So void power, as you can see, is one of the most volatile sort of ways that you can change, because void power changes. Well, yeah, I changed the void power by 10 times. If we changed either of these two values by 10 times, it's going to make a huge difference. But void power is something that can have a large difference in the game. So right now, here I'll give you a mathematical explanation of why nobody ever plays tier 4. So let's say our power naught, for simplicity's sake, let's leave both these two numbers 0. I can change them later to show you that it doesn't actually matter. And then let's say that to use enlightenment costs 260 power. So let's just put a 260 in here. Actually, that's not true. That's not quite right. So let's set that to 234. So this is our initial void power. So this assumes that one player started with exactly 300 power, and then one player played tier 4, which cost 300 power, and the other player played enlightenment, which costs 260 power, right? So this P naught is going to be 40. Does that make sense? Because, so originally it was 300, and then one player used all of it, so this goes to 0 for that player, and then the other player used 260, so this goes to 40. So let me just write another function in here, and let's change this V naught to V1, and let's change this P naught to P1, just to get a little distinction there, and we'll add sliders for P naught and P1 as well. Okay, so this function, actually let's just arrange it like this. So this function you see here in the black and the other functions in the purple, we haven't really adjusted that yet. So we'll say that both players are going to have the same wells because that's fair. And then this player that played the monument, his power not is going to be 0, right? Because he started with 300, he minus 300, which gives him 0. Let's just make that clear here. This is 300 minus 260. He's used his nice box where it's 40 and 0. And this player is going to have 0 void power, because when you put power into a monument, you get no void refund. Okay, so basically this bottom function is a straight line because everything's 0, and this top function models that if your only income is void. So as you see, the graph is going to level out here. It's 273. It's basically going to go to like whatever we started with plus 40. We started with 234 plus 40, so it's going to go to 274. This is going to approach 240 as you go to infinity, but you don't have to wait that long. You see that basically like here, it's 245. This is basically 200, and you know, there's not a huge difference between 250 and 274, right? So this sort of has a exponential function as it goes fast. So for instance, at 40 seconds, you're going to have 117 power, more than the player that played a monument. Okay, if you caught that, I said at 40 seconds when you can clearly see the marker is at 20. So the way this Battleforge power works is it gives you power every 2 seconds. So this time is actually measured in increments of 2. So at 20 intervals of t, in real time that's 40 seconds. So for instance, a monument is going to come up at 30 seconds. So if we set t equal to 15, there's probably a better way to do this, but I'm just going to slide along here. At t equals 15, the player that played Enlightenment will have 100 power more than the other player. So for instance, let's just assume that both players started with 300 power and nothing else, and then one player plays tier 3. Besides the fact that he instantly loses because he can't play any cards, the other player will be able to play an Earthshaker. If he enlightened and then Earthshakered, he'd be able to do that basically at the point in time when the player that played tier 4 got his tier 4 up. That's another thing that I would like to point out. I'm not sure how long Enlightenment lasts for, but I think it's 30 seconds. So let's assume that, let's just say that you timed everything perfectly, so it's going to last 30 seconds. So Enlightenment is going to last the same time as a monument takes to build. So if you have power to play an Enlightenment, let's say you have 300 power. So if you have 300 power and you spend none of it, then let's say you spend none of it and then your opponent goes tier 4. Then as soon as your opponent's tier 4 is up, you try to play an Enlightenment and you try to do an Earthshaker. You won't have the power to do that because all you'll have is the 40 power left over from playing your Enlightenment, because right away you're going to have 40 power. But if you play your Enlightenment 30 seconds before you need the Earthshaker, the void power refund from your Enlightenment will be 101. You'll have 101 power. Well, it'll be about 60 power because you got 40. But you'll have 101 power instead of 40 power if you play the Enlightenment 30 seconds early. So in the unrealistic scenario where both of you have only 300 void power and you have no wells, which actually I have seen happen before, but only when I was a noob. So it can happen, it's not a likely scenario. But if it does happen, just for a theoretical argument, if one player plays Enlightenment at the same time that another player plays tier 4, the player that played Enlightenment will have gotten enough power back from his void that he can immediately Earthshaker the player's tier 4 monument and win. So that was a little bit confusing. I hope you guys followed. The math, this isn't really a realistic scenario, where you're going to have 0 wells and no initial power. But I graphed it like this so that this axis is 0, and that way it's easy to compare how high this axis is compared to the other axis. So if we make, like, let's say wells are 4. 4 seems like a good number. If the wells are 4, then both players have a lot more power. You know, after 30 seconds, one player has 160 power and the other player is going to have 60, right? So there's still that roughly 100 power difference that we decided was going to be there at 30 seconds. But in this scenario, the player that played tier 4 is actually not quite so helpless. And let's say that we make this void, this is 234. Let's make this, let's add 300 to both. So let's say this is 300 or 534, and we'll add 300 here. This will just be 300. Now you see that these are closer. There's still a significant difference between the player that put 260 power in the void and the player that wasted that void power by putting it into his money, but it's not so significant, okay? So as you can see, the more power that players have, the more you can get away with playing an immediate tier 4. This is why sometimes tier 4 is played in 2v2, because in 2v2 you have a lot higher void power and you have, generally speaking, you have more wells than you would have in a 1v1 fight, which makes tier 4 playable, whereas tier 4 becomes much less playable the less power you have. So yeah, you guys can feel free to play around with these models however much you want, and I use this to compare two things, but you don't have to compare. You can just, you know, play around and see, oh, well, if I've got this many power wells and I've got this much power that I start with and this much void power, how much power will that give me back in return over this much time? Hope you guys found this useful. Thanks.